Types of level sensors. Level sensors can be classified into two main types: point level sensors and continuous level sensors. Point level sensors. Point level sensors indicate whether a substance is above or below a sensing point. They are used to detect excessively high or low levels. Point level switches can be used as alarms and to turn pumps on and off. Continuous level sensors. Continuous level sensor measure levels within a specified range and determine the exact amount of substance in a certain place. They indicate the level in a vessel over the full span of measurement. Continuous level sensors are used in applications such as fuel tanks and storage containers. Point level measurement sensors are 5 types: float switch level sensor, capacitance level sensor, optical level sensor, conductivity level sensor, and tuning fork level sensor. Continuous level measurement sensors are ultrasonic level sensor and radar level sensor. Float switch level sensor. The float switch utilizes a float, a device that will raise or lower when a product is applied or removed, which will open or close the circuit as the level raises or lowers, moving the float. This type of industrial level sensor is one of the most cost effective but well proven technologies for liquid level sensing. The float switches are non-power devices that provide a direct indication. They are relatively inexpensive. The disadvantages of a float switch are they are invasive to the product, having moving parts, and can be large in size. The float switches only indicates a low or high level. Capacitance level sensors. The capacitance level sensors are operated by using a probe for checking changes in the level. These level changes are converted into analog signals. Capacitance level sensors are very easy to use and clean, as they don't have moving components. Besides, they are very small, inexpensive than other sensors, accurate and invasive to the product. Applications: tank level monitoring in chemical, food, water treatment, battery industries and brewery industries. Optical level sensor working. If the cone is above the liquid, then the light will be reflected back from the cone to the detector. If the cone is below or submerged in the liquid, then the light will be reflected into the liquid and it won't reach the detector. So if the detector doesn't receive any light, then the light detector circuit would activate a control relay contact for alarms or control. Optical level sensors also don't have moving parts and are not affected by high temperature or pressure. Can be used in liquid applications and are small in size. They can be used as low-level indicators to avoid run-dry conditions when using coolant, oil or hydraulics. Commonly used applications like tank level measurement and leak detection. Conductivity level sensors. Conductivity level sensors, also called resistive level sensors or conductive probe sensors. It uses a probe to read conductivity. The probe consists of a pair of electrodes and applies alternating current to them. When a liquid covers the probe, its electrodes form a part on an electric circuit, causing current to flow which signals low or high level. Tuning fork level sensor. A fork-shaped sensing element with two tines is used in this type of sensor. The tuning fork vibrates at its mechanical resonance frequency of approximately 1200 Hz and is piezoelectrically energized. The frequency of the fork changes when the fork is submerged in the media, and this change is detected by the internal oscillator and converted into a digital output signal. Ultrasonic level sensors work by emitting and receiving ultrasonic waves at the range of frequency from 20 to 200 kHz. The waves are then replicated back to a transducer. The distance is measured by the time it takes for the waves to reflect back. Radar level sensors. These sensors send microwaves by an antenna on the radar sensor. The product that's being sensed reflects these microwaves back to the antenna, and the time from the emission to receiving of the signal is directly proportional to the level of the product.